Hello and welcome to Applicative Programming Demo with your boy Kyle. So I'm going to show you a little bit about how we use applicatives. So I mentioned in the last lesson this idea of applying functions. So if this is the data, that data goes into one function, and the output of that goes right into another function. Output of that goes right into another one. Output of that goes right into another one. This is a really powerful mental model for transforming data, because then each of these functions can be really teeny tiny, super reusable, super easy to debug, because none of them do all that much. But we can plug them together into one black box and then use it like one thing. Who can think of an analogy from CLI times? What else kind of worked that way?
When you separate out actions via the bar.
So when you have that bar, so like when I'm trying to figure out how many words are in the curriculum, I start by printing out all of the markdown files, and then I take the output of that and plug it into this WC program that tells me how many words there are. Gravy, that's a lot of words. So that's the idea of applicative programming. It's why it's called applicative. You are applying a function to just one stream of data. So our applicative functions, map. Map is transform. Filter is, call it thin out. There's some data that we maybe don't want. We can filter it. Find is get a match. There's some other ones too. Probably the most powerful applicative is reduce. It's like boil it down to one thing. All of those are examples of common applicatives that we use in programming. Oh, one more. For each. For each gets used for its side effects, but like a non-vocabby way to say that, we can just call it output. What's neat about these is that all of these take arrays in. Green. All of these take arrays in. And a pretty decent number of them take arrays out also. But every one of these is expecting an array as an input on that side. Map always returns an array. Filter always returns an array. Find doesn't. Find always returns one thing. Reduce always returns one thing. For each returns nothing.
Can the array have objects in them?
Absolutely. It can have objects, strings, booleans, objects of objects, even other arrays. So let's look at some chains. Chain. All right, so same thing from the last lesson. This is just the vanilla template on Code Sandbox. Got an empty element there. We can do whatever we want with it. Cool. So let's say I have the numbers 1 through 10. Come on. So I could put these through like a chain of transformations if I wanted to. I could do something like numbers.map, then take each number and double it. Okay, but think back to expressions. This is an expression. What does it evaluate to? Anyone?
Is it an array?
Mm-hmm.
It evaluates an array.
Evaluates to an array. Well, what we can do with arrays is we can map over them. So I could do a second map off of that if I wanted to. So convention is that when you're doing those, you indent them like one per line. So then on the next one, I could quadruple them if I wanted to.
But with each map, it's a new array. So now there's 3.
Dingo.
Total.
Like, yes, but they didn't get saved anywhere.
Right, because they don't have a whatever. You know what I mean? I know what you mean. Yes.
Cool. So yeah, that's the starting array. This turns it into a different array and uses that as the input to this map, which turns it into something else. So then I can go, all right, the smallest one is going to be 2, 8. I want to get rid of everything under 25. So then I could filter by numbers that are less than 25. And then, all right, so I've manipulated this array. Now I want to output it to the screen. So I can use my for each. And log each of those numbers. Cool, so I've got 3 numbers that made the cut. I could also say something like app.textContent plus equals the number. Or I could say maybe number with a space. There we go. So like three numbers survived that. And if I change this to 20, cool. Oh, it's going the other way. I do that. I get the big numbers. Make that 25. Cool. So that's what's neat about these. You can chain them. Ask me questions about that.
Yeah, just to clarify, so after map, everything in those parentheses, those are just arrow functions, right?
Just arrow functions. In fact, check this out. This is like one of my favorite things you can do with these. Is I can make a function called double that takes in a number and returns it doubled. this is exactly the same thing as this, which means I can do that. Made a function called quadruple. Or this function takes in a number and returns whether or not it's greater than 25. So I can make a function called is greater than 25. Takes in a number. Returns numbers greater than 25. And then that becomes is greater than 25. And this one, add to screen, takes in a number, does that, and then that function is add to screen. Cool. Now it tells a little story. Take the array of numbers, transform each one of them by doubling it, then take each one of those and transform it by quadrupling, then keep only the ones that are greater than 25, and then take every one of them and add them to the screen. That's what's cool about applicative programming. Questions about this?
This is constantly overwriting the original array, right? We're not creating new arrays with everything that you've done here.
We are creating new arrays. So numbers never gets touched. It's the input for this map. So double gets applied to 1, and then 2, and then 3, and then 4, and it just swaps them out. So those functions that you pass into map, it's like you called double 1, double 2, then double 3, and then made a brand new array with whatever the result of that is. So you end up with 2, 4, and 6. You applied that function to each of the values, and then made a brand new array with the results.
But because we didn't store that new array as a variable, we can't reuse it in any other function, right?
Correct.
Okay.
The only thing that it does is serve as an input to this next map. And then the output of that doesn't get saved anywhere. All it does is go into this next filter. And the output of that doesn't get saved anywhere. It only goes into this for each. But it doesn't matter because we end up just using it there. So it never gets saved anywhere. It's always in flight right up until it's on the screen. Cool. So, what a contrived example. Who wants to do this with numbers? This is stupid. So let's do some real data. What if, get rid of all this, get rid of all this. What if, Sharon's thing, what if we have an array of objects? This is going to be people. So the people have first name, last name, and age. Okay, so I've got this array of people. Let's say I wanted to take each of those objects and turn them into like a greeting string or something like that. So I could do something like people.map, take each person and return the template string I'm person.firstname, person.lastname, and I am person.age, years old. So we're taking an array of 4 objects, turning it into an array of 4 strings. And then I can take all that array of 4 strings and each over it. And maybe I turn each message that comes out of that, and I app.textContent, same thing I was doing before. I add whatever it is now, and then that message. Ta-da! Or maybe what I do is I turn them into, each of these objects into a string. And then I want to turn each of those strings into a DOM element, like a list item maybe. So instead of doing that, maybe I do map message, and I make a new li, document.create element, and I set the li's text content to the message, and then return the li. I'll just comment that out for a sec. All right. So I turned an array of objects into an array of strings, and then I turned the array of strings into an array of HTML elements, basically. Then I can take each of those for each li. I could do something like make a UL. And no, I'm going to make the UL up here in this other scope. So I don't make so I don't make 4 ULs. The document dot create element UL. And then for each li, I want to add that UL. And then when this is all over, I want to take app and add the UL to it. There you go. I didn't write any HTML for that, But if I element inspect that, check it out. A UL with 4 LIs in it.
Add it to your HTML? Or do you just see it in the oh, okay.
So I didn't write it that way. The browser renders it that way, though. These got added with JavaScript. They were never in the file.
So what if you had a bunch of content on your HTML file and then you added that? Where would it fall in place?
Wherever you tell it to. So in my case, this app element that I grabbed, which is this thing here, when I call append on that, I'm saying, hey, make a new node on the tree with this UL that I built up.
Does it still follow your CSS, your style sheet properties?
Yep, 100%.
So that would be the benefit of like using tag selectors, right, over like classes and stuff, since they'll automatically fall into place.
No, that doesn't make an impact. So like here, we got it by ID there.
But I mean, like the LI. So like if you were styling originally, if you were styling all your LIs with classes and stuff.
Not necessarily. So what I could do is when I make this LI, I can say li.classlist dot append person. And now, oops, is it not append? Is it add? Yeah. So now if I inspect that, they all have that class. And then the real winner here, I'm still hard coding all this data, which like is nice. That's a hell of a lot better than writing out 4 or 40 or 400 LI elements in an HTML file. But let's say I don't have the data at all. It just comes from another source entirely, like an API. Well, I might do something like fetch from the Pokemon API. And so that's going to give me a big old list of them. And then I can parse the response. And then take that response. And then if I log the data that I get back from this, check it out. Oops, something I didn't like. pokeapi.co/API/v2/Pokemon. Why didn't that come back with anything? That's fine. Maybe I need to refresh it. What was just the response? All right, we got, oh, it's results. There we go. Not data. All right, so I have this list of 20 Pokemon. Okay, cool. And then it has a URL where I can get something other than the name. I'm going to start with just the name for now, though. Also, I bet I can make that more if I add a query string. Say limit 2000. There we go. That's a whole big ass list of Pokemon. All right, so if I take the results, const, So that Pokemon list is an array of like 1,200 Pokemon. I could map over that. Do something like Pokemon.map. Or since those are the same, that's legal. It'll just shadow. I could say like Pokemon list. So they're at least different words. And then I want to only get back the name. So right now it's a name and a URL. I want to map over that object and turn the object into a string. So I could say like, all right, just give me Pokemon.name. So that turned the list of objects into a list of strings. Then I can take that list of strings and then maybe I make li elements for those. Create element li, and then li.textContent for each name, singular. Make list items for those. Oops, actually, I'm going to map that. Then return the li. And then I'm going to each over the LIs that I just made. I'll make a UL over here. Document.create element UL. For each LI, append it to the UL. And then, actually, I'm going to do the append up here. App.append UL. There we go. It's a list of every old Pokemon in there. Oh, but wait a minute. Their names aren't capitalized. So maybe that's just another mapping that I do. So I take this list of lowercase names. And transform the name. Where it's like name dot to uppercase. Sorry. Name at 0 to uppercase. All right, so now they're all uppercase letters. And then I want to append that to like name.slice at 1. There we go. Now they're uppercased. It's just another transformation. I didn't write any of this stuff. It's somebody else's data. I just got it off the internet. But I can do all of these cool iteration tricks and transformations to make them whatever I need to make them. Ask me some questions.
If you wanted to store the array, how would you do that?
It's tricky because of these thens. So what this means, like this has to go to outer space and back. Who knows how long that takes? Who knows if it even works or not? So I controlled like, all right, these can't happen immediately. They need to wait for this to be done. Same thing here. This could take who knows how long. So this doesn't run right away. It just waits for the other thing to be finished. That's not the case with these. Like, these work as fast as your computer works. There's not a chance for anything to happen in between them. That's not the case with HTTP requests. HTTP requests, we got to wait for it to finish, and then we got to say what happens when it wraps up. So if I wanted to take this list I can totally do that, but it needs to be something where like I maybe return Pokemon list here, and then whatever else I wanted to do with that would have to happen here. That's a more advanced one. That's kind of a next week problem, but there we go. There's all the objects. Another example of what we could do. Let's say I want to turn these into my own object. Oh, actually, this will be even better. So I'm going to delete all this. I got my Pokemon list. So if I look at that again, okay, so I got 1,126 objects that came back from this API. Each one of those objects has two properties, a name with that string, and a URL with where I can get more stuff about that particular buddy. So what I want to do is I want to tell the browser to go look that stuff up. I want it to go to that URL, because if I go to that URL, I get things like images. There we go. There's those pictures that I want to use. I want Squirtle and Bulbasaur. I want a whole bunch of pictures. So I can map, come on. I can map each of those URLs into, like I could transform this URL string into an HTTP request. So that would be like, I got a Pokemon list, map over it, and I just want the URL. All right, so I've turned an array of objects into an array of URLs. Here, I'll prove it. URL. So if I console log URL here, I should get 1,200 strings printed to the screen. Just did something wrong. Why doesn't it like that? I goofed up something. I haven't spotted it yet. Why doesn't it like that? If I save that.
Do you have to have Pokemon list in front of both maps? Or no?
No, because it'll
Okay.
chain. I think my computer might just be
Frozen.
I think that's what's happening there.
Just trying to help.
Doing great. All right. Back in business. There we go. So there's all the URLs that I got. All right, cool. I'm into that. Now I want to turn each of those URLs into an HTTP request. So I can return fetch URL and then I want the parsed version. So I'm going to do that. All right, so now I've transformed. Come on. Any day now. Oh man, I am taxing this poor puppy hard. All right, I still really want to show this to you though, so let me, maybe I should do it locally. Pokemon Shower. All right, I'm going to put that code in there and then grab this HTML. Come on. Get there. All right, one more time. All right, and then I'm going to grab that HTML and put it here. All right, back in business. Cool. Okay, so I've turned a list of objects into a list of URLs, turned that into a list of HTTP requests, and then what I'm going to do is I'm going to execute all of them at once. And then I'm going to take the responses that I get back, and for each one of them, I'm going to turn my array of HTTP responses into an array of LI elements. So I'll do responses.map response, and for each HTTP response, I want to make an LI. I want to make an image. I want to set the source of the image to whatever the response is, sprites.frontDefault property is. I want to append the image to the LI and then return the LI. And then for each LI, I want to put it on the page. So that's in UL, so it'll be UL append LI. All right, moment of truth. So it broke. Might just be slow because it's getting 1,200 things back. Let's see. Let's see if these responses came back. Something I didn't like. It's not in source index.js, just in regular index.js. Okay, did I get here? Can be helpful to sanity check your files. So like, I'm not seeing that in there. Oh, there we go. Oh, there it is. It really did just take a while to do 1,200 HTTP requests. All right. Wait for it. Suppose I didn't have to do this with all 1,200 of them. There we go. So each one of those responses, come on. There we go. Let's see what they look like. All right, that's taking too long. Let's knock it down to 10. Start there. Before I get my IP address banned. Come on. Man. Should be. Localhost 3001. There we go. Ta-da! And so then if I made that 20 instead of 10, there's 20 Pokemon. All that stuff is data transformations. I got a list, I got an array off the internet. That's this right here. I turned that array of objects into an array of URLs. I turned that array of URLs into an array of HTTP requests. And then I fired off all the HTTP requests at the same time. When I got them back, I mapped over each of them to transform the HTTP response into an LI element. And then for each one of those, I added them to the page. Magic. And imagine that these aren't Pokemon. Imagine they're, I don't know, student performances or evaluations. And you're making them all show up in a list on a page. Ta-da, welcome to Web App
Pokemon.
Yes.
Got a new one today on Pokemon Go. Woohoo!
Nice. That's web app development in a nutshell. Questions?
So some of this, go ahead.
No, please go ahead.
So I know, like, I get your logic, right?
Mhm.
And of course, we're not going to be able to do any of this for a long time, maybe a
I
little.
don't know.
not-
You'll probably be able to do what I just did
Yeah.
by the end of next week. That wouldn't
Okay,
surprise
so
me.
we'll be able to do it next week. But as far as like some of your syntax where there's parentheses and inside the curly braces and all that stuff, if I were to try to recreate this, I would get lost on just that.
Sure.
So is there a syntax rule that is, I know MDM, right? But is there like a term of art that you can give us for like just kind of remembering where to put the parentheses and the
Sure.
curly braces and all that stuff?
Absolutely. So one, your text editor will help you out with this. We installed some stuff on day one, especially if you use the auto formatting, that like takes care of a lot of that for you. Now that said, let's look at like some of the weird syntax things that we have here. So that's a variable assignment. Nothing crazy there. Nothing crazy there. This is invoking a function. That function happens to be on an object, so we can dot off of it. Same thing there. This fetch returns an object that has a method called .then, and like that's one of our syntaxes that we learned in the last lesson for functions. That's all that's happening there. You're passing in a function definition to a method. Ta-da! Same thing that's happening here. This looks like a lot, but if I take out that stuff, well, we know this. That's just one of our syntaxes for writing functions. And we're passing it into another function. So if you keep breaking this stuff up, you keep seeing stuff like that. Like this map here. Oh, what do you know? If we take out the parts that aren't mapping, it's a lambda. We take out the parts of this that aren't map. Lambda. Just a method call. This one here, oh, we got a lot going on there. But if I take this out, hey, what do you know? Lambda. So there's some like conventions that people have to help with readability and conciseness on this, so it doesn't take up so much of the screen. That's all that's happening with any of these. Lambdas on lambdas on lambdas. And then like if I take these out, we're just chaining stuff off of other things. Because if this evaluates to a map, or sorry, if this evaluates to an array, well, we can call map on arrays. So like I may as well be doing that. That's all that's going on.
The one thing I haven't seen that I've been looking for all day, and I can save this for the study hall if I need to,
Sure.
is a map function with an if statement inside of it.
Okay. Like there's nothing
Yeah,
special about that. So this could be if URL is some truthy value, then return that. If it's not some truthy value, return, I don't know, something else. Now, ideally, you like it's not great to use a conditional inside of something like this. Like in general, it's like conditionals are not awesome. They're one of the first things you learn in programming, and I have plenty of ifs and elses and all that kind of stuff on like the LMS code. That's the first stuff I try to get rid of because there's almost always a way to rewrite something without if statements.
That's what it feels like, because it hates my syntax every which way. So I might show it to you later at the study hall.
All right. And if you go, but Kyle, how on earth could you write logic without if statements? Isn't that selection? Isn't that one of our core fucking things?
That's what I need it for. Yep, something like that.
Awesome. Well, here's me doing a talk on why I don't like if statements and how you get rid of them. But that's another like super advanced thing. For right now, use if statements like everybody else does. Yeah, there's nothing special about the syntax inside of a Lambda.
I'll think I'll have to show you mine because I'm testing it in the console, and I've been doing this for hours, and it hates every way I try it.
All right. I haven't seen any questions in the queue about it. All right. Yeah, we can talk about
I
it in
posted.
study hall.
Yeah, I was gonna say I've got one posted in the queue, and John left me a note, but it's and he did help me out a lot with the other parts of the syntax. But the if statement is the last piece that's not. If I remove the if statement and try it without it, it works great. But as soon as I add that in there, it's throwing a curveball.
All right. Other questions about mapping, filtering, any of that kind of stuff?
This might be too basic for this group, but could we just do some bare bones examples of filtering, a bare bone example of a mapping, something like that?
Yeah. So, bare bones as you get is that stuff I was doing earlier. So we could turn those into other numbers. Or how about we transform them all into Booleans? So I put it like a 0 in there. I want to start with a thing of numbers, and then I want to turn each of those into Booleans. So if I log that, or I guess if I each do that, for each Boolean, add it to the text content. Ta-da! Or if I want to do that, and then I want to, anything that's true, I only want to keep things that are true. So then I can filter number and I could do number equals true to keep something like that. Now I get rid of that false one. Strictly speaking, that does the exact same thing. It's called an identity function. You pretty much just use them in filters to, it's like, by the way, if something was false, I don't want it anymore. And then, but I'll keep it the other way for now. So I only want those, and then I want to take everything that's left, and I want to map it. Or maybe maybe you don't even need to use whatever that thing is. So then I want to turn all of these into strings. That's about as bare bones as you get. Numbers to Booleans to strings, throw them all on the page. More questions?
How would you do a filter off of an index? Just the index slot alone?
Just the index.
Well, so we have an array here, and I'm trying to isolate down part of this array, but not the entire thing.
Okay.
But I'm trying to do it off of its place within
Gotcha.
the array itself.
So map, filter, for each, and find all get an optional second argument called, you can call it whatever you want, but it's the index. So if I do that, and maybe I only want to get the even ones. So then I can do like modulo index equals 0. Or doesn't equal 0. So you could do something like that. You could do it with, we put a body in here. Here's your if statements. So if I say like const legal indexes are 0 and 4. And then I can return whether or not legal indexes includes whatever the current index is. So I could filter that way. And if I get rid of that. I'm still curious why that's not. Oh, it's because there's not a fourth index. There we go. I could try to get the index on this one. So it's not going to be the same index because I filtered stuff out. So by the time it was mapping over, there was only 2 things to map over. But that'll work. I could do that as an if statement instead by saying like, if legal indexes includes index, return true, else return false. That's the exact same thing, just with way more lines of code. Still works. Anything else?
I would say thank you for showing us a lot of this, because I was really hung up on the, we talked about it earlier, the syntax using the map. And just watching you do this, I was like, and I started plugging into the code that I've been having issues, and I'm like, oh, now it's working because I'm using the wrong syntax. I'm plugging the things in the wrong place. I was trying to figure out how to capitalize that first letter on the words, and I had the code for capitalization, but I couldn't figure out where to put it in. And then, yeah, so it's thank you.
Excellent. Glad to hear it. Yeah, what's cool, like, and this goes back to the functions thing. If you have a function that takes in a word and uppercases the first letter, now that can be a standalone piece of logic. It doesn't need to be in a big tangle like this, or even worse. Oops. Come on. Something like this. Like anything that you can extract and make its own standalone function so you don't have to find it in some 115 line monstrosity. Now you don't need to consider the other 115 lines. If you have a 1-line function that all it does is uppercase something, it's so much easier to think of that little piece all on its own and make sure you're confident that that does what you think before you're also trying to figure out how it works in this giant rat's nest.
And if it's something that is a function that's going to uppercase something, you can declare it as a function. It doesn't matter where you put it, right? Because it'll always be in scope. Okay.
And then you can even have just little standalone functions. They're called utilities that do things like format dates or uppercase things. Maybe not all that special to your app, but you can isolate that logic so that you can think about only what that's doing and not worry that something else is the reason that it's not working. All right. Well, I'm going to call that good on the map filter find for each demo.